Explosions Incorporated. Last week I made a video about the 5 common signs of a chemical reaction. This week I wanted to focus in on one chemical reaction in particular called combustion, the 3 things that are necessary for combustion to happen, and a little bit about the oxidation process that underlies that reaction. And I think most of us are pretty solid on the idea that fire needs at least 3 things to happen. At the minimum, you need a source of fuel, you need a source of heat or ignition, and then you need oxygen. If you combine all 3 of those in the right way, you get the combustion reaction we call fire. Now, in Don's video the other day, where he goes over all the elements, he touched really briefly on this idea of oxidation. Technically, it is when an atom loses one or more of its electrons as it combines with oxygen. You can also think of it just as it's oxygen combining with other elements, and then what happens? So, for example, your apple turning brown after you cut it open is oxidation. Rust forming on metal is oxidation, and fire is oxidation. In fact, rust and fire are the same exact type of oxidation. The one big difference, though, is how quickly it is happening. See, you can have just about anything as a fuel source. Anything that can be combined with oxygen that you can apply energy to raise it up to the point of ignition. So you could use paper, you could use wood, you could use oil, a bunch of things like that. Same thing with the energy source. It doesn't have to be an existing fire. Fires can be created using friction, other things like that. Anything that generates energy and gives you that heat. Oxygen, however, is the one sticking point. You have to have oxygen if you're going to have fire. No oxygen, no oxidation, no fire whatsoever. I can actually illustrate this pretty well just using a few ingredients. This is a Lycopodium powder. It's a very, very fine powder. Tiny, tiny particles. Feels very, very soft. It feels kind of like baby powder. Very, very small particles. It comes from a moss. It's an organic substance. What we're going to do is this is going to be our fuel source. I'm going to add heat in the form of a burning match. And of course, we are surrounded by plenty of oxygen, well, 20% oxygen or so. So let's put these 3 together. Now, we did not get the combustion reaction. In fact, we got the opposite. The fire that I already had going went out. If we do the same thing, we use the same ingredients, but instead of taking the match and putting it into the powder, this time what we're going to do is we're going to use a stationary flame. We're going to use this candle, and then I'm going to apply the powder directly to the candle. We got a really different reaction this time. See, the difference is this. We have fuel, we have energy, all around us we have oxygen, but inside this cup, this superfine powder, tiny, tiny particles that fit together, they fit together so closely that inside of here is what we refer to as like an anaerobic environment, an environment that does not have oxygen in it. No oxygen in here, plenty of oxygen out there. So when I take the powder, mix it with the oxygen. It's called aeration. All of a sudden it goes from being non-flammable to extremely flammable. This is the idea behind things like grain silos exploding. A lot of organic substances will do this. They are inert, they are non-flammable until they get mixed with oxygen. All of a sudden then they become a wonderful fuel source. You have fuel, you have energy, you have oxygen, and you get fire. Well, that's a little bit about fire, oxidation, that chemical reaction. I think maybe next week I'm going to do a brief video on what happens to the energy that is released when this chemical reaction known as combustion happens. Thank you very much for watching. I'll see you guys next time. I'm Aaron from Explosions Incorporated.